AQUABIZ, all the best knowledge for aquatic system.
Okay, for this morning, I'm going to talk about how we can increase survival and growth rates of tilapia and carp in our hatcheries through proper nutrition and feeding. The slide is just showing us the global fisheries and aquaculture production in 2020. As you can see from the slides, the total fisheries and aquaculture production was about 214 million tons. And just for aquaculture production, there was 87.5 million tons. And in Asia, aquaculture production was about 77.38 million tons. And you can see also from the figure, the increasing trend for the market. So that means that aquaculture is indeed in demand. And there is more reason for us to really produce high quality fingerlings that we can use for intensive farming. Because for export, what are required of us is like fillet. This is a big size fish. China still leads world aquaculture production, okay? And of course, Southeast Asian countries like Indonesia, Vietnam, Philippines, and Thailand are also producing. Although as you can see from the slide, the Philippines and Thailand is quite a bit, needs more improvement, okay? So probably there are many factors why we have more or less stayed on a constant level compared to other countries. Okay. What you have here on the slide is a general life cycle of fish. Okay. Of course, it depends on us how we start the cycle. You can start as broodstock, or you start growing the fish, fry to broodstock. Nevertheless, for broodstock, we need good genetics, good nutrition, okay? Good nutrition is important because the broodstock are the ones that are producing the future fish. So we want good eggs, good fertilization rate, good hatching rate. And nutrition is a big factor. Of course, we cannot underestimate the importance of genetics because we may have very good nutrition, but if our broodstock is not genetically good, then it's a big challenge. In the life cycle of a fish, for example, it's a hatchery nursery that is quite critical. Critical in the sense that feeding is very challenging, especially from larvae to fry. Survival is quite challenging at that stage, okay? Very vulnerable. So it is important for us to really observe good nutrition, quality nutrition, and good feeding practice for our hatcheries and nurseries. Okay, I think we are all aware that 60% of the cost of production is feed, okay? Maybe even more than that because cost of ingredients have increased, okay? And we also realize that we need to give the highest quality nutrition, okay? Especially in our hatcheries. And this is essential because we need to produce a very high quality juveniles, meaning good quality good survival that we need for intensive systems. There are many concerns, of course. I have only listed a few here. Of course, there is always the concern for poor growth, low survival, again caused by many factors, diseases. But at the moment, I think most of us are concerned about the high cost of feeds. Okay? It is everybody's concern. Okay? However, we need to realize that good nutrition is definitely going to improve growth rate, survival, and even minimize disease. Okay? So it's kind of a situation where we have to embrace that problem, that high cost of feeds, okay, if we intend to produce a good quality fish. There are many reasons why we feed our fish. Okay? For one, we need feeding our fish to achieve good reproduction. And earlier in my slide, good reproduction means good hatching rate, good larvae, good fertilization. Okay. I'm not going to talk on the nutrition of broodstock because I'll just focus on fry fingerlings. Okay. We also need to feed fish because we want to economically grow healthy and high-quality fish. So we want to produce large-sized fingerlings, maybe about 25 to 30 grams, that we can use for intensive culture. Okay. And we need to improve the health of our fish. That is to assure us of a good survival. But most importantly, we need good quality of water. Okay? Good water quality is very, very critical in every stage of the life cycle of a fish. You can have the best quality, nutrition, you can have very good genetically improved fish, but if the water quality is poor, then we cannot achieve our goals. It would be very difficult. There are different systems of producing larvae to juveniles. We have the extensive, semi-intensive, and the intensive systems. I think you're all familiar with the extensive, where natural food is available. Okay? We need good pond preparations, and we have low stocking density. For those who are doing the semi-intensive, usually we have a little bit higher stocking density than extensive. There is still the presence of natural food, but we also give supplemental diets. These supplemental diets are not really complete compared to the complete diets that are given in the intensive system. Because in intensive systems, you have a very high stocking density, okay, and usually this type of production systems are practiced by commercial aquaculture. Okay. Therefore, there is a need to provide complete diet. Okay. I am not focusing very much on the types of natural food, meaning the live feeds, because my good friend, Professor Hin, will be discussing the different live foods that are given, for example, in catfish and pangasius, but they are also given to, say, tilapia and carp. Okay. So we want to achieve, or we want to produce, good quality fingerlings. To me, I would consider a good quality fingerling as a fingerling with high growth rate, okay, high survival. High growth rate, meaning you can grow the fry, like 0.2 grams of fry, up to, like, say, 25, 30 grams in maybe 2 to 3 months. So that would be a good growth rate. Okay. But in order for us to achieve high quality fingerlings, we need to have a very good quality of feed. We need to focus on the right proportions of nutrients. So you need a balance, okay, to have an efficient feed. Okay. So the balance, the right proportion of the nutrients are important. Okay. Feed quality is important, but the feeding practice or the management is as important as feed quality. So when I speak of good feeding management, I would refer to feeding correctly. There are many things that we can do to feed correctly. For instance, we need to really feed the correct nutritional quality. Okay? We need to give feeds with the correct size, meaning you don't give a small fish with small mouth with a big pellet, or you don't give a big fish with a larger mouth with a small pellet, because efficiency will be wasted. Okay, it cannot be optimized. Okay, so you also need to give the correct amount of feed, and we need to feed at the right time. For instance, in tilapia, we don't feed after 4 in the afternoon because tilapias are daytime feeders, and they will stop feeding after 4 in the afternoon. And that is based on research that we did at the CIFDEC Philippines. There are many aquaculture species that would require live feeds. Okay? Giving live food is really good because it will cut down cost. However, there are some constraints, and I think we are all aware of this. We need space, for instance, and dedicated staff to maintain, for instance, the population density of the live foods, for example, of moina, of the copepods, of the zooplankton that we give our fish. Many times, we also need to do some enrichment, okay? And again, we try to look for alternative live feeds. Nevertheless, giving live food will cut down cost. Okay. Fish larvae usually survive the very early stage of hatching on the yolk sac. Okay, so those of us working on tilapia, you know that you have the yolk sac fry. Okay, those yolk, it's a reserve food for the fry. When the yolk is finished, then tilapia can feed on live foods if live foods are available. Okay. Generally, the live foods, like different species or strains of fish, would prefer different types of live foods. What I meant was, for example, tilapia and common carp, they are considered herbivores, meaning they feed on plants, but they are also considered omnivores, meaning they can feed on phytoplankton, they can feed on zooplankton, and they can feed on benthic organisms, especially the common carps. Okay. There are fish that are really herbivores, and a good example is the silver carp. Okay? The silver carp feeds on phytoplankton. By the way, one characteristic of the silver carp, if you have experienced this, is it's like, you know, the jumping trait of the silver carp. It's a very movable, very active fish. And when we do sampling, it can even jump as high as a meter. So it is I call it the jumping carp, the silver carp. Okay. Now the grass carp, just from its name, feeds on grass, okay? It feeds on soft aquatic weeds. So these two are herbivores. And there's another type of carp, the bighead carp. The bighead carp are zooplankton eaters. So they feed on the zooplankton. Okay. So these are different types of species that would prefer different types of live feeds. Okay, in hatcheries also, we wean, meaning we move from live feeding and we give commercial or manufactured feeds. Now, the type of commercial feeds developed by feed millers or manufacturers are determined by the larval size or the stage of development. Okay. For instance, in the Philippines, feed companies would develop feeds for very small fish, 0.2 grams to 5 grams, and then a different type of feed for a bigger fingerling, a different type of formulation for juveniles and then adults. So development of this would depend on the life stage of development of the fish. There are supplemental diets, and as I mentioned earlier, it has incomplete nutrient content, but the complete diets contain all the required nutrients. So those are the requirements for commercial feeds. Now, there are different types of feeds, forms of feeds. As I mentioned earlier, we have the mash or the powder type. These are usually given to very small fish. Okay, we also call this the fry mash. You probably have this also here in Thailand, fry mash. And then we have the crumble type. Okay, so we call it the starter crumbles. Okay, and these are given to fish that are a little bit bigger. Okay, and then we have the pellets. There are pellets for juveniles, and there are also pellets for adults. Okay. There are two different types of pelleting. You have the extruded, and you have the pressure pelleted feeds. Now, extruded types are floating. They are buoyant. Okay. So one advantage of giving this is that if you are feeding your fish, you can immediately observe if the feeds are eaten. Okay, because it's floating, it's buoyant. Extruded pellets are given if the feed needs to stay at the surface for some time. Okay? Now, the pressure pelleted or the sinking pellets, it also has its advantage and disadvantages. It's advantageous for those fish that feed in different water columns. Okay? And this is not on shrimp, but shrimps are bottom feeders, so sinking would be good for them rather than extruded. Okay. One disadvantage of the sinking pellet is that if the feeds are not eaten, okay, then this can add to the poor water quality. Okay. So these are generally two types of feed formulation, extruded and the pressure pelleted. There are different ways of delivering feeds. Sometimes we determine the ration or the amount of feed that we give, and we also determine the time of feeding. So this is predetermined. Okay. There is also the demand or the self-feeding, wherein it's the fish that demands when it's hungry. Okay. And you tell the farmer, I'm hungry, I need to be fed. So it will do something, and then feed is available. So we have this predetermined or demand feeding, but you can do it by hand, okay? Or by hand if labor is cheap, okay? But when labor is not cheap, then it is the mechanical feeders that would be more advantageous because it would require less people to maintain. Hand feeding will generate employment, okay? But again, depending on the labor cost. This is a slide that I always include whenever I do lectures, anything on aquaculture. Okay. Aquaculture has really improved, for example, fish production, because we know that the fisheries is declining. Capture fisheries is declining, and it is aquaculture that has sort of provided food, fish. But aquaculture can have a very negative impact on the environment, okay? Especially if we feed in excess. Okay? Whether the environment is cages in lakes or cages in ponds or just earthen ponds, eutrophication can happen. Okay? When we overfeed, okay, when there is excess feed not eaten, we have what we call eutrophication. In the picture, you have very green water, and I think you're all very familiar with this. That means you have an overbloom of algae. Okay. And this can lead to fish kill, as it happens very often in the Philippines, in Laguna de Bay, one of our lakes. And that other picture is Lake Toba in Indonesia. Of course, you can ask me, why is it a problem when fish can eat the algae? The thing with algal bloom, when there is an overproduction, okay, the algae will compete for oxygen. Okay? All organisms require oxygen for cell respiration. Okay? So when you have this bloom, the algae now is going to compete with the oxygen in the water. And that results to low dissolved oxygen in water and can result to fish kill. So management of our feeds is really important because of this problem. Okay, so I was talking earlier about nutrients requirement of fish. Okay? I have listed down here 5 major important nutrients. You have proteins, carbohydrates, lipids, vitamins, and minerals. Again, there is a need to have an appropriate balance, okay, for good feeding efficiency. Okay. The trend nowadays is to adopt a precision nutrition, okay, wherein the approach is to have all the essential nutrients and needed additives in the right proportion and balance in the feeds. Protein, the protein energy ratio should be balanced in fish feeds. Now, the need for an optimum protein energy is important because this will give us optimum growth. Okay? It will improve survival of fish, it will improve reproduction, and also improve the immunity of the fish. Generally, protein energy ratio is higher in early stages or in small fish. And this decreases as the fish grows. Okay. For instance, in tilapia fry, the ideal ratio is 123 milligrams of protein per kilocalories. Okay. Again, we have to keep in mind that there is no single method or procedure for all the things that I'm going to discuss here, because every country would work on different species, different environmental conditions, okay, different types of feeds. Okay. So I cannot tell you that this is the only procedure that we need to follow. Okay. But there are general guidelines, okay, that are required or common to all countries. Now, for example, if you give if the energy is very high, this is also not very good because this can lead to high fat accumulation in the carcass. And many times, this one is also not good for the fish. Of the nutrients that I've talked about, protein is the most expensive, as I think you all know. This is also the nutrient that is given the largest quantity. Why? Because we need protein to grow. We need proteins for maintenance. Okay. We need this for building muscles in fish. And when I say good quality protein, I refer to digestible protein. Proteins that are digested easily by fish. Okay? And proteins that would have the essential amino acids. Okay? Amino acids are the building blocks of proteins. In organisms, actually, we need 20 amino acids for our building blocks, but not all of these are produced naturally by fish. Some needs to be given in the diet. Okay? So, digestible protein with the essential amino acids. Generally also, there is a higher requirement for proteins in early life stages in smaller fish. In high density culture, there is also a need for a high protein content. Okay. Another nutrient that we should have in our diet is carbohydrates. Okay? This is a very good source of cheap, non-protein energy. Carbohydrates are also very good binders. Okay? So it allows the feed to float, stable. Okay. And carbohydrates are also good because they increase the retention of protein and lipids. Okay? They are essential also for our diet. Okay? Lipids, okay? These are the essential sources of good fatty acids. Okay? They are good because they provide metabolic energy, okay, for, again, growth and reproduction. And most importantly, they are carriers, okay, of non-fat nutrients, meaning fat-soluble vitamins like vitamins A, D, and K. Okay, so they are carriers. Two other nutrients, the minerals and vitamins. Like humans, fish also need this. These are essential chemical elements that we need for metabolism. For minerals, some are given, the macro minerals like calcium, phosphorus, they're needed for the bones of the fish, of course. So we refer to them as macro minerals. There are micro minerals like the zinc, cobalt, manganese, selenium. These are also required by fish, okay? Good for normal metabolism and even improves reproduction in adults. Okay. Now, vitamins, okay. For humans, we need vitamins to glow. Okay. Fish also require vitamins. These are essential, again, micronutrients. And the most common and we're familiar with are the vitamins A, D, E, K, B, and vitamin C. Okay? These are good not just for growing our fish to fingerling, but they're also needed for good reproduction. Okay. There are many advances now in doing or in manufacturing commercial feeds. And one of the important focus is to look at the amino acid profiles. Okay? We need to be aware that the feeds we are buying or giving our fish has the right amino acid requirement of the fish, say for tilapia and for carps. Okay? Amino acids, as I mentioned earlier, is the building block. Okay? And they supply energy in a very available form. Of course, my good friend here already mentioned the advantages of using soybeans. And I'm not going to go into that. Yes, in the Philippines, we use a lot of US soybeans. I'm sure you do here also in Thailand. Okay. I was talking about amino acid requirements. For tilapia, there are 10 essential amino acids. Okay? For common carp, there are 12 essential amino acids. Of course, it is hard to say whether the feed that you are buying has this, but there are tests. Okay? You can actually do some testing with respect to digestibility of your feeds, with respect to the presence of these essential amino acids. Okay? There are tests that are available. Feed quality is essential, but feeding practice or feeding management is as important as feed quality. Like, we do not want to overfeed our fish because this will result in the loss of profits. Okay? If you overfeed and the fish don't eat the feeds, then, it's a loss. Okay? And at the same time, this can also degrade the environment. Okay? If we underfeed our fish, on the other hand, it's still a loss, economic loss, and this can also result in poor growth and survival. See, there is a need to balance feeding. And there are many ways there are many practices that we observe. I have listed down here some of the practice that we do, and this can again differ from country to country. Okay? How we implement this also depends on our type of fish that we work with. For instance, the particle size. Okay? I think it's common sense not to give a big fish a big pellet to a small fish. So some of these practices sometimes would also require good observation and good common sense for the feeder. Okay. Feeding rate, we're all familiar with the feeding rate, and it's just deciding on how much feed you give, but it's based on the fish biomass. Feeding frequency, how often we feed our fish. Smaller fish, they like being fed many times. Okay, many times, meaning you can do between 3 to 5 times a day. Okay, for small fish, they need to grow. Okay, for bigger fish, you can reduce the feeding frequency. Time of feeding, okay, especially if it is predetermined, would be good to feed your fish about the same time. We also need to train our fish when they eat, when they expect. But of course, the demand feeders, they will just demand what time they want to eat. Okay. So the feeding method, as I mentioned earlier, it's either given broadcast by hand or automatic feeding. Now, one very important thing for me, personally, is record keeping. Okay? Unfortunately, many of us do not keep good records. There is a need for this data system. We need the data of stocking, fish weight, what type of feed we give, because we need this for management. If we have to adjust our density, if we have to maybe change the brand of our feed, okay? When we do measurements, we know that our fish is not growing. We need to record all of this, okay? Record keeping, database information is very, very important. Okay. Feeding rate, frequency, again, as I mentioned many times, this is a function of the size of the fish. This would vary depending on the stage of development and the size of the fish. I have here on the slide, and this is based on, like, say, research and findings of many studies, okay? Protein requirements of tilapia, okay? Again, according to life stages and weight. For larvae, tilapia larvae would require about 45 to 50% protein. Fry and fingerlings, like say 0.02 to 10 grams, would require about 35 to 40%. And as the fish grows, increases in size, then we can reduce the protein requirement. Okay. Also, for crude lipids, okay, we can give between 10 to 15. Okay. There is a trend now to give a high lipid of, say, 10 to 11. Okay. So crude fiber, okay, we need a low crude fiber because if you have a high crude fiber, that means digestibility is not good. Okay. One of the advantages actually of soybean has a very low crude fiber, meaning it has high digestibility. This is a slide I modified. Well, I modified in the sense that I only got the important data here, but this is feed, a practical diet that is being used in China. Okay, I don't know if they're still using this. For fry, they give a very high crude protein. It's about 49.5. This is in their intensive culture. Look at their crude fat, it's about 13%. For fingerlings, like say 10 to 50 grams, their crude protein is about 35 and the crude fat is 12.4. I have included here a paper, okay, where I based this table. We go to feed conversion. We're all familiar with the word FCR. Okay. In farms, we need to have an indicator whether our feed is efficient or not. At present, and to my knowledge, there is yet no absolute indicator for feed efficiency. But in the absence of that, the FCR is still our best bet. Okay? It is an indicator whether the feed is efficient. Now, why do I say it is not a perfect indicator? Because FCR can vary depending on the season, okay? Depending on the type of feed, okay? Depending on the species, so there are many factors that can affect FCR. For instance, even if we feed, not all the feeds are eaten, okay? Or there can be mortality, okay? So FCR, calculating FCR is still essential, even if it is not the perfect indicator of feed efficiency, okay? There are many factors that can affect feeding or feed efficiency. An FCR of 1.5 to 2 is considered good growth, generally. So if we have an FCR of, say, below 1.5, well, that's a very good one, okay? So we do not want a very high FCR. Okay? So there are things that you need to put into the calculation, so that is the reason why we do sampling. Okay. 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 I'm conscious about time. Okay, so I hope I'm not talking very fast. I tend to do that. But the reason we do sampling, regular sampling, is we need to know the weight of our fish, okay? We need to know the number of fish that survive. We need to measure how much food we give, because this all go into the calculation of our FCR. I did not include here how you calculate, because I think this is basic to all of us, but you need the wet weight gain, okay, how much your fish have gained. Okay. We always talk about feeding our fish, but there are times when we should not feed our fish. Okay? I have listed down a few of the things that we should avoid doing, okay? Because if the response of our fish is poor. Fish is not eating, there's no sense feeding the fish. You'll just pollute the water, kill your fish, and economic loss, okay? When we do harvest also, or we have to transport fingerlings, we do not feed our fish, tilapia or carp, because it will stress our fish, okay? When we do sampling, okay, we try to rest our fish, no foods are given, just to make sure that they're not stressed. Water temperature. Temperature is a very important abiotic factor that affects feeding, okay? There is an interaction between, for example, dissolved oxygen, temperature, even salinity, and feeding, okay? When the temperature is very low, okay, fish like tilapia will not feed well. But the common carp has a high tolerance for cold water temperature. So a common carp can feed. But if the temperature is also very high, okay, like say above 32, 33, then tilapia will not eat that well. So we have an optimum or a range of temperature. So we have to be observant. Feeding also very early in the morning is not advisable. Why? Because dissolved oxygen is low in the morning. Now, why is it low in the morning? Before the sun rises, the algae will not undergo photosynthesis. And we know that in photosynthesis, oxygen is released. Okay. When there is no photosynthesis, oxygen is not released by plants. Okay. In the absence of sunlight, because we need sunlight for photosynthesis, and very early morning, we don't have that sun yet, so dissolved oxygen is low. Okay. So that's the reason why we avoid feeding very early in the morning. Okay. For tilapia also, tilapia is a daytime feeder. Based on our study in CIFDEC, tilapia will stop feeding around 3, 4 in the afternoon. Okay. So we tell our staff, we stop feeding, like say 4 o'clock, because we will just waste our feeds. Okay. So we have to be conscious of those things, because feeding is good, but sometimes you have to stop feeding. Okay. Part of a good feeding practice is to be observant. Okay? In CIFDEC also, we always tell our staff, our laborers, or whoever is helping us in the experiment to observe the fish, okay, when feeding. Okay. I have included here, like say, 4 criteria, okay? Excellent situation. The fish are very active. They will immediately come to whoever is feeding. They will fight for the feeds, and in no time, the feed is gone, okay? And then, it's good response, okay? The fish are less active, but nevertheless, they will maybe come for a very longer period, they will feed, okay? They may not finish all, but maybe in 20 minutes, they will consume all the fish that you give. Now, fair response, okay? The fish are slow, they can be sluggish, okay? So maybe they're still sleepy, like me, and then they will feed about 75% of the feed in maybe 30 minutes. Then you have that very poor response when they just do not want to eat, okay? So there are many reasons why a fish will not respond to your feed. Maybe the feed is not good tasting, not palatable, okay? Or the fish is really sick, okay? For tilapia fry, a good indicator that the fish is not well is when you see the suddenly dark coloration in the body of the tilapia, okay? When you see that, you have this dark coloration, then the fish is under stress, okay? When a fish is under stress, like humans, when we are sick, we do not want to eat, okay? So good observation is important. That, I think, is a very practical feeding practice that we often do not follow, okay? Because when we are instructed, for example, in the pond run, we are instructed, okay, you feed 3 times a day, okay? Just give the feed. Doesn't matter if your fish says, no, I don't want to eat. Okay, so good observation is important. I did mention that there are factors that affect feeding. There are many factors, okay? Abiotic. Temperature is one very important factor to consider in feeding. Okay. My apologies, I did not include dissolved oxygen, but dissolved oxygen is, as I have always mentioned, is important. When there is low dissolved oxygen, then don't feed. Okay. Photo period, okay, especially for temperate fish, not much for tropical fish, because some fish are night feeders, some would be daytime feeders. For our tropical fish, usually they are daytime feeders, okay? Of course, our husbandry practice is an abiotic factor, and the characteristic of feeds. For example, how dense, the density of your feed, if it's a floating type or it's a sinking type. So these are factors that can affect feeding. Okay. Biotic factors, okay, depends on the species, depends on the strain. Okay? There is no, again, one general rule that all Nile tilapia strains, for example, would follow the same routine. Okay? Here in Bangkok, I know that you have many genetically improved tilapia, and they may differ in some of their response. Okay? It also, biotic factors would also depend on the life stages, as I have always mentioned. Okay? Feeding behavior of fish, okay? That matters. Okay? Social behavior. They also need to maintain social distancing. Sometimes, when the density is too high and feed is not enough, then even tilapia will resort to cannibalism. Okay? When density is very high and food is not enough for every fish, then cannibalism cannot be avoided. Even for fish like tilapia, who is by nature not a cannibalistic fish. So these are just some of the factors that can definitely affect our feeding. Okay. Okay. The other things to consider also is the anatomy and physiology of our fish. For example, here in tilapia, there are mainly herbivores, and being herbivores, they would have long intestines. If you dissect your tilapia, you see that the intestine is really long. And that is a characteristic of phytoplankton feeders, of herbivores. Okay? Tilapias also, they have small tube-like but functional stomach, okay? But very long intestine. And tilapias require high protein diets, okay? So they can tolerate high, if you give them high proteins. They are daytime feeders, and they also respond very well to more frequent feeding compared to other fish. Okay. Okay, carps in general, these are stomakless fish. So it means they have no gastric glands that would produce acid and enzymes. Okay. They also have long intestines. Okay. They have closely spaced gill rakers, and this is a good anatomy for filter feeding. Okay, feeding algae, feeding on zooplankton. You need to have those fine gill rakers, and they have very powerful pharyngeal teeth. For instance, the grass carp, they eat on grasses. They eat on soft aquatic weeds. Okay, so they need to have powerful pharyngeal teeth. Okay, so remember, common carps in general are stomakless fish. I've listed down here the most commonly cultured fish in Southeast Asia, you have the bighead carp, the silver carp, the grass carp, and the common carp. So the digestive anatomy and the physiology of the fish also would affect feeding. Earlier on, I listed nutritional requirements for tilapia, and here I have listed nutritional requirements of cultivable carps, and I base this on the National Research Council nutrient requirements of fish. Okay, so you have here also the protein, carbohydrates, fats, vitamins, and minerals. Okay, and my last slide. Okay, just some recommendations for us to be able good or high quality fingerlings, like fingerlings that we can grow up to 20 to 30 grams in 3 months or less. Okay, we need good water. Okay, good water quality is essential. Okay, there is a need to select the proper digestible feed. Digestible feed, because that means what you're giving your fish will be converted into mass, into growth. Okay. Then our feeds should have optimum daily supply of essential nutrients, and we have just discussed that earlier. Yeah. Good feeding practice, okay, is critical. Okay. And again, up-to-date records. Yeah, I always include that. So in all my lectures related to aquaculture, whether it's broodstock development, breeding, nutrition, I always emphasize water quality. Yes. Good genetics, I did not discuss genetics here because it belongs to a different topic, but it is important to have a genetically good fish that is not inbred. When you have an inbred fish, the inbred fish will be very vulnerable to diseases and mortality. And therefore, no matter how good your feed is, but if you have very bad fish, then our goal of achieving a high-quality fish with good growth, high survival, will not be achieved. And with that, I thank you, Kapkunka, for listening to my talk. Thank you.